In this video, we're going to be tackling the LeetCode question, trapping rainwater. This is a hard question, and what I've done is I've created a story, and if you can make it through the story, I guarantee you, you will understand trapping rainwater in depth. You won't even have to stay for the coding part, but I highly suggest you do because I need the watch time. Anyway, let's go ahead, let's jump right into the story. Let's say that you are walking through the Appalachian forest. It is a cold spring morning and you are having the time of your life. And suddenly, upon walking through this trail, you meet the devil himself. And the devil himself, he hops up on a log and he says this to you. He says, I've been seeing you walking, I've been seeing you frolicking, looking all cute. And I've got a game for both of us. And this game's going to make both of us wealthy men. And of course, you take him up on his offer because you're an American and you do deals with the devil all the time. And the devil says to you, if you can jump over my stick, if you notice the devil actually has like a stick. So he says to you, if you can jump over my stick, I will give you this stick. But if you can't jump over my stick, you have to pay the difference between what you jumped and the height of the stick. What exactly does the devil mean by that? Well, if you can't jump over a stick, let's say instead of 5 feet, you jump 3 feet. What you're going to have to do is you're going to have to pay $2. But let's say that you are lucky enough to actually jump over the stick. The first scenario was when you couldn't make it over the devil's stick. Let's say that you actually make it over. And let's say that you jump 6 feet. You actually jump 6 feet. So that's 1 foot over the stick. Well, you don't have to pay the devil anything because you now own the stick. You are now the new max, and you get to collect fees on anybody else who can't jump over the stick. But, funny story, how does that actually relate to trapping rainwater? Well, let me put it to you this way. This question is the two-pointer question of the century. It does not get any more two-pointery than this question. And all that we're going to do is we're going to place a pointer at the very beginning and we're going to place a pointer at the very end. And we're going to play the devil's game wherever the smallest number is. And after we get done playing the devil's game, we're going to move that pointer towards the center, whichever side that we're on. So we're currently at the first pointer because 3 is less than 4. And what we're going to do is we're going to play the devil's game in our head. Is 3 beating anybody else? Or do we have anybody else we're even, quote unquote, competing with in the devil's game? No. So 3 is automatically the devil's stick. And we're going to go ahead and we're going to move it forward. We're going to play the devil's game again. Does 1, quote unquote, jump over 3? No, it doesn't. So what we have to do is we have to pay. But instead of paying, what we're actually doing is we're filling it up with water, so to speak. We're taking that difference. And when we take the difference between 1 and 3, what do we get? We get 2. And what we're going to do is we're going to store that amount in a variable called water because that's our water. Then we're going to go ahead and we're going to move our pointer up once again. And just like before, what we're going to do is we're going to play the devil's game. We're going to check, does 2 jump over 3? Is 2 more than 3? No, it's not. So we're going to take the difference. And that difference is going to be 1 unit of water, which we will add to our variable up top here so we can keep track of it. We're going to move the pointer once again. Does 0 beat 3? No, it definitely does not. And what we're going to get is 3 units of water, which we will add to our variable keeping track. But here's where things get a little bit crazy. 5 is now the larger number. So what we're going to do is we're going to play the devil's game at the other side, which is 4. 4 is automatically the max. And what we're going to do is we're going to increment it. And we're going to play the devil's game. There's 3 jump over 4. No, it doesn't. So what we're going to do is we're going to take that difference and we're going to add it to our water. Finally, we get to the end where the two arrows meet, and that's going to trigger the end of our algorithm. Let's go ahead, let's hop over into IntelliJ, and let's code it. So we are inside of IntelliJ, and the first thing that I'm going to do is create a brand new Java class, and I'm going to call this solution. Within the solution class, I'm going to create a method to house our actual algorithm. It's going to be public, of course. We're going to return an int, and we're going to call this trap. It's what LeetCode gave it this name. I did not name it trap. I know it's not very descriptive, but it's what LeetCode wants, so it's what LeetCode gets. Next thing, as with any algorithm, we're going to go ahead, declare our state, then we're going to start our iteration. For our state, we have a 2-pointer type algorithm here. So we're going to have our pointers, which are going to be left and right. Left is going to start at the beginning, right is going to start at the end. Then what we're going to have is we're going to have our maxes. If you don't know what I mean by maxes, remember back to the devil game analogy, the stick. These are actually the sticks. This is what you need to either exceed to create a new max, or what we use to calculate the difference of the water. Speaking of water, we also need to create a variable that's going to store our water. Since this is a 2-pointer algorithm, what we're going to have is a while loop. And this while loop is going to be controlled by the expression left is less than right. What this does is the 2 pointers are going to be moving towards each other. And eventually they are going to meet. And when they meet, we want to break out of this algorithm. But what are we going to do while the algorithm is actually running? Well, remember, we have 2 pointers, and within these 2 pointers, what we're going to do is we're going to have to play our devil's game. We're going to have to perform our logic, but there's 2 pointers going on, so we're going to have to do one at a time, and we're always going to choose the bar with the lesser amount, with the lesser height. Once we're at the lesser height, we can finally get to the good part. We can finally code the devil's logic. And the devil's logic is very simple. If we exceed the height, which it looks like this, we're just going to calculate the height.left, and we're going to check if we exceed the left max. So if we exceed the left max, what we're going to do is we're going to recalculate our left max. We're going to reset it to the new height. But if we don't, here's where we're going to add our water. This is where we're going to calculate the difference of the left max and the left height. And that simulates the devil's game, so to speak. And finally, at the very end, we can't forget, we also have to increment. We have to move our pointer over. And finally, the only thing that we have left to do is we need to perform the devil's logic on the right side. And it's going to be incredibly easy because IntelliJ is going to take care of it, most of it for us. But let me just explain it to you really quick. All this is doing is it's checking the right side. And if the right side is greater than the max, we're going to go ahead, reset our max to the newest max. But if it's not, it means that we went under. So we're going to go ahead, we're going to add that difference to our water. Don't forget, you also need to decrement the right because the right moves in towards the center, or moving towards the center. Finally, we can go ahead and return all of this, and we should be good to go. So I'm going to go ahead, copy all this. I'm going to copy down to the return. Go ahead, hit the copy button. We're going to get out of full screen mode here. Going to bring up LeetCode really quick, and we're going to test this. So I'm going to go ahead, bring this over. Go ahead, toss in the code. Looks good. Let's go ahead, run our test cases. Thank you, God. Almost was going to have a heart attack if that didn't work. So let's go ahead, check our time complexity. Time complexity is looking good. Let's see. We are linear, and our space complexity does not get much better than that. Hope you guys enjoyed this. If you did, make sure to smash that like button, smash that subscribe button. And as always, thank you for watching.